Section 5.5, the substitution rule. Very important section in Calculus 1. So here what we're going to learn is, we learn to introduce what we call the substitution method or substitution rule to help us with integration. Imagine in the previous section, let's say, imagine we had this one, 2x, x squared plus 1 to the third power dx. We're asked to integrate such an integral. In the previous section, what we did, we expanded the x squared plus 1 cubed, and then we multiplied this by 2x. But that is going to take a lot of time, especially if you don't know the formula for a plus b cubed. Well, luckily enough, there's an easy way. The easy way says, you let part of it. For now, it's hard to explain why is this, but as we do more examples, it will appear. You'll see the big picture out of this. We take this part here for now to be u. So let u equals x squared plus 1. And then differentiate both sides with respect to x. So the derivative of u is u prime. Derivative of x squared 2x plus 0. U prime means du dx is 2x. Or you can rewrite it, rearrange it like this. That's du. So I'm going to transform everything from x into u so it's easier to integrate. So what I do is 2x dx, this one here, get replaced with du. And this part is u to the third. So then this becomes u to the fourth over 4 plus c. But u is x squared plus 1. So x squared plus 1 to the fourth over 4 plus c. See how it became easier? Because we started with x, we cannot end up with u. We have to end up with x. That's why we substituted back in. Let's look at another example. X sine x squared plus 1 dx. Where's the u? This is going to be the u. U equals x squared plus 1. And look what you can do. You can straightforward say du instead of writing du over dx. Du is the derivative of this times dx, say. So do I have dx and x? Yes. Do I have the 2? No. 2 is missing. So let me rewrite the problem again. So what I'm going to do, because 2 is missing, I'm going to put a 2 here. So this way it becomes what we need. But since I put 2 here to balance it, we multiply by 1/2 outside. So I multiplied by 1/2. So the 2x dx, this part is du. And this is sine of u. So now the problem was transformed from this ugly stuff to 1/2 sine u du. 1/2. What's the integral of sine u? It's negative cosine u plus c. But again, we can't just end up with a function in terms of u. There has to be, instead of u, put x squared plus 1. So x squared plus 1. Next one, the integral for the square root of 4x plus 1 dx. What do we do here? We take u. What can be u here? U is 4x plus 1. What's du? It's 4 dx. So we need 4 here and 1/4. 4 and 1/4. So 1/4 stays the same. Square root of u du. Like that. How do you integrate something like this now? We rewrite the square root of u as u to the 1/2 du. And this becomes what? 1/4 u to the 3/2 over 3/2 plus c. The 3/2 get flipped 2/3 u to the 3/2 plus c by 2/1 by 2/2. So this will give us u to the 3/2 over 6 plus c. But what is u? U is 4x plus 1. So 4x plus 1 all to the 3/2 over 6 plus c. Don't forget plus c, because that gives us the general antiderivative. Another example, it's a matter of practice, cosine x over 1 plus sine x dx. So what is the u here? Well, if you take sine only, then you will get cosine on the top, but then you're going to have maybe du over 1 plus u. Then you have to do it again in that sense. So what about if we try the whole denominator to be u? U equals 1 plus sine x. Du is the derivative of x, the derivative of 1 is 0, derivative of sine is cosine dx, which I already have up there. So this becomes du on the top and u in the denominator. But what's the du over u? That's natural log of absolute value of u plus c. And then replace u with 1 plus sine x plus c. The absolute value, you know, you can drop it because notice we know that sine x is between -1 and 1. If you add 1 to all sides, then that quantity under inside the absolute value is from 0 to 2. So that's a positive. So you can drop it, drop the absolute value plus c. What about looking at the same problem, but I'm going to change sine into sine square. In this case, if I take u equals 1 plus sine square, the du is not going to be on the top. Instead, I want to think about a different thing to take for u. Maybe choose u equals sine x. What is du? Cosine x dx, which you already have there. That's du. Let's see how this will turn out to be. On the top you get du. The bottom 1 plus u squared. What's the integral of du for 1 plus u squared? This is tangent inverse of u plus c. But u is sine x, so tangent inverse of sine x plus c. That's what we have. Next one. The integral of ex minus e negative x over ex plus e negative x dx. What we can do, we can take the denominator to be u. Du is ex minus e negative x dx. So that's what we have on the top. So it's the du over u. That gives us the ln of the absolute value of u plus c. And then we replace the u with ex plus e negative x plus c. But this quantity is always positive. Because this is positive, their sum is positive. Because they fall about the x-axis graphically. What about integral of e8x dx? Recall, e to the u du is eu plus c. So here what do? We take the top to be u. Let u equals 8x. Du is 8 dx. So we get 8 e 8x dx and 1/8 outside. So you get 1/8 e to the u du. 1/8 e to the u plus c. But u is 8x. So now, what about another example? E to the x square root of 1 plus ex dx. What can be a good choice for you? U, if you take the outer one u, then du is not going to be there, or it can be so, but it's a long method. What about taking inside the square root to be u? Du is, the derivative of n is 0, derivative of ex is ex dx. And that's what I have here, ex dx. So the square root of u du. But this is u to the 1/2 du. This becomes u to the, if you add 1, becomes 3/2 over the same thing plus c. But you can flip the denominator, makes it 2/3, u to the 3/2 plus c. And u is 1 plus e to the x, 3/2 plus c. What about another example? As I said, it's a matter of examples. The more you practice, the better you become with this. X square root of x plus 2 dx. Same kind of like, same concept. You take the stuff under the radical is the u. Du is dx. So what do we have? This is the square root of u, and dx is du. But what is x here? What is x? X is u minus 2. So u minus 2, like that. And now we have u minus 2 to the u to the 1/2 du. I'm rewriting it so I can multiply it inside. U times u to the 1/2 is u to the 3/2 minus 2 u to the 1/2 du. This becomes u, add 1, 5/2 and flip it. Minus 2, add 1/2 and flip it. Plus c, flip the exponent like the 3/2, make it 2/3. Now nothing can be done with this one. This one is 4/3, u to the 3/2 plus c. But it's not done because we can't end up with a u. It has to be in terms of x. Replace u with x plus 2. So 2/5 x plus 2 to the 5/2 minus 4/3 x plus 2 to the 3/2 plus c. Next one. What about if it's a definite integral? So we have to be careful with definite integrals is that the u here, originally this means x from x equals e to x equals e squared. When we do u, a choice for u here would be ln of x or natural log of x. Du is 1/x dx. So this part is du. So this becomes what? Du over u. But it's not e to e squared anymore because we're doing with u's here. So I can leave it like as an empty spot like this. The integral of du over u is ln of natural log of absolute value of u from somewhere to somewhere. Natural log of u is ln of x from e to e squared. Now we need to substitute the e squared first, minus substitute the e next. So let's keep this the same. Bring the 2 down. Ln of e is 1. Ln of e is 1. 1 times 2, 2. Ln of 1 is 0. So the answer is natural log of 2. Natural log of 2. Now there are two things, important things to learn in the substitution method or substitution rule. First one, as part of this section, if we suppose that f is continuous, is a continuous function over negative a to a, then part A, if f is even means f of negative x equals f of x. Then even means symmetric about the y-axis. Watch what's gonna happen. Let's say the function goes like this, just for simplicity. This is the function f, and then the integral from negative a to a of f of x dx. So it means if you want to find the area under the curve from negative a to a, this can be done by going just from 0 to a, because it's simpler for substitution, and double that because the two sides by symmetry are the same. Two sides by symmetry are the same. What about if f is odd? F is odd means f of negative x equals negative f of x. Then what do we have? Then the integral from a to a, f of x dx, is equal to, watch what's going to happen. Odd function it's symmetric about the origin. So something like this. So this is A, this is negative A. This whole thing, what is this? This is gonna be 0. Because both of them are gonna be, by symmetry, have area A, but this one is a negative A. Like means because it falls below the x-axis. If you look back about 2 sections back, we did explain our last section. We explained if the area falls below the x-axis, it's negative. It's just the negative an indication it falls below the x-axis. So the integral would be 0 in this case. Now how do we apply it to examples? Let's say we're asked to integrate from -1 to 1 x to the 9th plus x over x squared plus 16 dx. If you try use substitution or any method by rewriting algebraically or trig or anything, it's not going to be easy to integrate this, or almost impossible. But what we do here, first thing as an indication, when I see these numbers that are opposite of each other, that reminds me of think about if it's even or odd. Where's the function? This is my function. So the function I have is x to the 9th plus x over x squared plus 16. So what I'm going to do is I'm going to find f of negative x, which is negative x to the 9th plus negative x over negative x squared plus 16. That gives us what? Negative x to the 9th minus x over x squared plus 16. We can take a negative outside, negative sign out. So that gives me x to the 9th plus x over x squared plus 16. So that's f of negative x equals, that's a function itself, negative f of x. Oh, that tells us it's an odd function. This is an odd function. So if it's odd function, the second property here said, part B, if it's odd, automatically the answer is 0. Since f of x is odd. It's odd function. We can look at another example. The integral from negative pi to pi, sine x over 1 minus x squared plus x to the 4th dx. Again, this is not easy to integrate by u sub or any other method. But if you look at these two, they are opposite of each other. That reminds me to test if this is an odd function or not. So the function is f of x equals sine x 1 minus x squared plus x to the 4th. So we need to find the f of negative x. That's sine of negative x over 1 minus negative x squared plus negative x to the 4th. And let's see what we get out of this. F of negative x equals sine negative x. That's an odd function. We call them odd even identities. That's a negative sine x. 1 minus x squared plus x to the 4th. So notice this is the function f of x. So f of negative x equals negative f of x. So that's an odd function. So then, if that's an odd function, this is 0. So on any test or you're doing homework problem, do not just write equals 0. You must show it's an odd function. That's the most important part of this. You must show this function is an odd function. Otherwise, you cannot just write equals to 0. I'm going to do one more problem on, let's say, x squared plus 7 squared dx from 0 to 1. So another definite integral from 0 to 1. And let's see how this works. Again, by u sub, you take x squared plus 7. The quantity inside the powered one, like x squared plus 7, something powered, that's your u. So du is going to be 2x dx. Du is 2x dx. So then, what do? We need that 2 here, multiply by 2 and 1/2 outside. So that equals 1/2 integral. 2x dx, that's a du, and u squared. But it's not 0 to 1 anymore, from somewhere to somewhere. So keep 1/2 the same. U to the 3rd over 3, from somewhere to somewhere. U is x squared plus 7, x squared plus 7 to the 3rd power over 6, from 0 to 1. You see, when I I start using 0 to 1 as soon as I get everything back to x, because this means from x equals 0 to x equals 1. Now, we are going to substitute by the fundamental theorem of calculus the top one first, the 1 first, 1 squared plus 7, all to the third power over 6, then the 0 next. So what do we get for this one? That's 8 to the third power over 6 minus 7 to the third power over 6. Okay, so then all we have to do is we are going to calculate each one. This is 512 over 6 minus the next one is 343 over 6. So what does that give us? 169 over 6. So 169 over 6. If you want to write it as a mixed fraction, you can do that. This is 28 and 1/6. Or you can leave it like 1 or 169 over 6. It doesn't matter. So this section is really important for all the subsequent chapters in Calculus 2. It helps a lot. This is the basic foundation. If you can master this section really well, then it will make things really easy for you. Really easy for you. Just keep that in mind. The more you substitute, the better for you. So one more time, if we go back to the original one, notice how we started by selecting the value for u. We took the quantity that is being cubed, or the quantity within the trig function, or the quantity under the radical sign. These three things give us a lot of keys, a lot of clues what to do. So for this, or something in the denominator, total in the denominator, or part of it in the denominator, as it happened here, part of it in the denominator. So you don't take the one on the top. Here we took the denominator to be our u. Denominator is u. Or anything on the top of ex. So that could be like ex squared. So you take the x squared to be u. Anything on the top of u is going to be our u. Under the radical, as you can see. Under the radical is our u. Something in the denominator, not all of it, but part of it. Here it's a complicated one, and it's a definite integral from somewhere that are opposite of each other, so we think about odd functions. Same thing happened with this example. And this one we took the stuff that is being raised to some power as our u. So those are keys for picking what u could be. Something being raised to a power, under the radical, something in the denominator, or fully in the denominator. Those are the keys to help you pick up what you could be. But again, practice is the most important way of learning this section.